Okay, today we're going to talk about the new formula, which is the ideal gas law, and you can see that is right here. PV equals nRT. So the way it's going to work is you'll have 4 of these variables, and you'll have to solve for the other one using a bit of algebra. So maybe they give you pressure, they give you moles, they give you R, they give you temperature, and you have to solve for volume. Okay, so you're going to always have some of these variables, and then there's just going to be one that you have to find. Okay, so we're going to talk about the new variables. So the first new variable is R. And so if we look over here, it says that R is called the ideal gas constant. And so the trick there is that it said the word constant, meaning it is always the same number, right? So it's always going to be the same value. Now, there are multiple different values for R. And so what I do in this class is I have you just use a single R value, so you don't have to remember multiple, but that does mean that everything has to be in a very specific unit. And so we need to look at that next. So pressure has to be in ATMs. Volume has to be in liters. Temperature has to be in Kelvin. And then N, which is moles, we've had moles before, moles have to be in moles. So one of the things about the way I teach this is that I feel like students are more successful if they just are juggling one value for R instead of juggling multiple. And so different teachers are going to teach that differently. But in this class, we're going to try to consistently use 0.0821 as as the value we use for R. So when you are plugging R in, it will always be this same number. Now, the problem though with always using the 0.0821 is that you have to have ATMs, you have to have liters, you have to have moles, and you have to have Kelvin. Now, let's say you had a different R value. If you're using a different R value, then the only thing that actually changes is that this could be in millimeters of mercury, it could be in kilopascals or pascals, but we're going to keep this simple. We're going to have pressure in ATMs, we're going to have volume in liters, we're going to have our moles, and then we're going to always use this value for the constant. The R value constant is going to be 0.0821. So one of the main things is getting the correct units when we set these up. So we're going to slide down here and we're going to look at an example. And so you can see in the notes I talk about R and I talk about everything, but right here I just give you this chart and I say, okay, you've got to have these units. So when you're going through your problems, make sure to double check. You have atmospheres, you have liters, you have moles, and you have Kelvin, and then everything should work out fine. Okay, example problem 1. Now, not a ton of space here for me, so I'm going to kind of do some of it in this white space over here to the right of the table. So it says, determine the volume occupied by 2.34 grams of carbon dioxide at STP. Okay, so one of the ways that you know you have this type of a problem is that you're going to notice that they only give you one of each variable. You don't have 2 of anything. If you had 2 of something, we got to go back to the combined gas law, PV over T equals PV over T. What's also missing from this particular formula is that you do not see grams, you do not see moles. And so if you have grams or moles, you're going to be using the ideal gas law. And so if you take a look, this problem says we have 2.34 grams. So right away we know that this has to be the ideal gas law. So we're going to be using our pressure times volume equals N times R times T. So you should just write down these variables and fill them in. So let's write down pressure equals volume equals N equals, And then over here, it says run out of space. We'll put the R. We'll put the R here. And then we'll have to slide the T kind of over here. All right, so pressure. Determine the volume. Okay, well, right away, I haven't talked about pressure yet, but it says determine the volume. So let's go over here to volume, and let's put in our question mark, because that is what it wants us to find. Determine the volume occupied by 2.34 grams of carbon dioxide. Okay, that is not moles, but we have solved this a lot, and so you should be able to take your grams and turn them into moles. So 2.34 grams of carbon dioxide, if I want to convert those into moles, which we have done this a significant amount, then you would just look up the molar mass for CO2, which is going to be 32 for the oxygen plus 12.01, so you're going to get 44.01 grams per mole. And that's how you're going to get moles. Again, grams are not moles, but you have the ability to convert grams into moles if you have the formula, which you do. So I run that through, and we're going to go with 3 significant figures or 3 numbers in our answer. And so I'm going to go with 0.0532. Now, if you just did 0.05, that would be fine, but we're going to try to be consistent here. So that's going to go in for my n value. So I'm going to put that in here. I'm going to go 0.0532. Right, so that's moles. Good to go. All right, so let's go ahead and clean that up a little bit. Kind of got messed up, so let's clean that up again. 0.0532, and there we go. All right, now we don't have all our variables. We need pressure, we need R, we need temperature. So it says right here, determine the volume occupied by 2.34 grams of carbon dioxide at, and there's the key, STP, standard temperature and pressure. So remember, you get to pick. Well, if it's my choice and I need ATMs, I'm forced to have ATMs for my pressure, I'm just going to go ahead and put 1 ATM, because remember, 1 ATM is standard pressure. So pick the 1 ATM and off you go. So standard temperature, what is that? Well, standard temperature, remember, was 0 Celsius or 273 Kelvin. 273 Kelvin. That's going to give me exactly what I need. I need a unit in Kelvin. No conversion. Very nice. And we said that the R value is always going to be the same value. We're going to be always using right there 0.0821. So we're going to put that right here, 0.0821. So now we have all the variables, everything we need to solve this problem. So we're going to go ahead and give us a little space. I'm going to clean this up right here, give a little space, and we're going to run this through. Now at this point, you are just plugging in the numbers and you are doing some algebra. So let's go ahead and do some algebra. So we're going to go PV equals nRT. So P is going to be 1. It's going to be 1 ATM. Actually, let's clean that up a bit. All right, let's do it like this. So it's going to go 1 ATM. That's my pressure. So 1 ATM. I'm going to multiply that by volume, which is my X. I'm going to set that equal to N. So here's my N value. So 0.0532 moles. And then R, I'm not going to write the unit down because it's kind of complicated, but it's going to eat up all my space. But if you slide up here, it's just ATMs times liters over moles times Kelvin. But you don't really need the unit there. You'll solve it fine. And then right here, 273 Kelvin. Okay, so when we look at this, we can just double check. I mean, there's your P, there's your V, there's your N, there's your R, there's your T. Got everything that you need. And so now all we have to do is solve for x. And so solving for x here, pretty straightforward. It's just going to be, x is going to be by itself, and then you're going to be 0.0532 times 0.088. Got messed up. Let's go fix that. 0.0821 times 273, and of course divided by 1 makes that very easy. And so that's pretty straightforward. So we run this through, and I ended up with a volume of change the color here. I got 1.19. So I got 1.19. Now what is the unit? Well, the unit is going to be liters, because it's going to always give you the correct unit if you put in the correct unit. So that is 1.19 liters. Okay, so now you know how to do this. You've kind of seen an example. So what you should do is try to work this example number 2. So go ahead and try example 2, and then what I'll do is I'll walk you through that one by just kind of using the same overall idea. PV equals nRT, set up all your variables, and you should be good to go. Main thing is to make sure you have liters, atmospheres, moles, Kelvin, and then go ahead and use the 0.0821 for R. All right, so here are the variables. Let's see if you got them correct. So I had pressure, and notice that 1482 is not the correct unit. That's millimeters of mercury, so this isn't going to work. So I had to divide by 760 to get to ATMs. So I need to get the ATMs, so I did that. Liters, volume, good to go. They gave us liters. Moles, check, they gave us that. And then Kelvin is what we're looking for, so it's going to give an answer in that, so I don't have to worry about that right now. But I do need to make sure to convert. This is the problem. Most students would have trouble right there, so make sure you didn't have trouble converting into ATM. So now let's just set it up and run it through. Okay, so I set it up here. Save a little time. I went ahead and put everything in. So remember, same formula, not changing anything. So it's just going to be PV equals nRT. And so here's my pressure in ATMs. Very important. There's my volume in liters. This is my moles. So they gave us a value already in moles. There's the R value. So remember, we're always using the 0.0821, and then of course we're solving for temperature. So I run it through. Basically, to isolate for X, you take 1.95 times 12.30, which I did right here, and then you multiply those two and then divide it by 0.654 times 0.0821. Make sure to use parentheses on this part so that your calculator doesn't give you the wrong answer. So just make sure you're using parentheses there. And then I got 447 Kelvin. I went to 3 values there, 3 sig figs, and you can round however you want, but that's how you should look at it. So, all right. So you guys have some practice down here. You guys can work. I've got your R value there. I got the formula, and you got some problems to work through. So just check your units, take your time, and you should be fine.